Okay, we're going to go through the sigma notation and the nth term. First, the uppercase. It's just like in our alphabet. There's lowercase, uppercase. The uppercase sigma. If you start out with just a horizontal line, okay, and another horizontal line down here, okay, that is the uppercase sigma. And sigma means summation. You should have already seen that symbol on a menu bar on Excel spreadsheets in computer apps. That's the auto sum button. You know, if you wanted to add up a column of numbers real quick, you use that auto sum button because it means summation. Okay, that is just a shortcut way of writing a series. We've been talking about series with plus or minus signs. They will give you, and I'll give you some examples here. Say I give you the summation of, and they will put a formula out to the right, the summation of 3n. They have to tell you where n starts for n equals 1 to 4. Okay, that would be a formula, okay, written in sigma notation. Okay, and if you want to simplify that, you start substituting in that bottom number, 3 times 1, and it's a summation plus 3 times 2 plus 3 times 3, and then you stop when you get to that top number, 3 times 4. Okay, and then you'd simplify that out, 3 plus 6 plus 9 plus 12, and then if you add that together, sum of that should be equal 30. Okay, that's writing it out. This is writing it out in what they call expanded form. Okay, let's look at another example. Say I give you the summation, and that's how you read it, summation of 3k minus 2. They have to give you the formula out at the right. And let's say k equals 6 to 8. Okay? And then start substituting in. I would probably use a bracket. So you'd say 3 times 6 minus 2, close the bracket, plus 3 times 7 minus 2, close the bracket, and then the quantity 3 times 8 minus 2, and that's where you stop when you get to that top number. Okay, and then if you simplify this, you'd get 16 plus 19 plus 22, and add those together, you get 57 for your sum. Okay. Okay. Let's look at another example. Say I give you the summation of 3 to the x power plus 1. The 1 is off by itself. 3 to the x power and then plus 1, and x equals 4 to 7. Okay, so that actually means 3 to the 4th plus 1 plus 3 to the 5th plus 1 plus 3 to the 6th plus 1 plus 3 to the 7th plus 1. Now, I could punch that in on the calculator just as it is right there and get my answer. Okay, but luckily Texas Instruments has helped us out on the calculator. Okay, if you go to your calculator, we are going to put this in using what they call sum, and in a lot of ways I wish it said sum series, but it says sum sequence. Okay, and if you go to your calculator book, okay, it would say put in your expression here, or your equation. It'll probably say variable expression. Then it will say put in your variable. Then it will say do the start, do the end, and then do the increment, how you're counting. Okay, so you have to figure out, and there's two parentheses, two left parentheses, so you always need to match those up with like two right parentheses. Okay, now this sum on your calculator is under second function list. Okay, so on your calculators, if you look right above the, and I would probably put the key, look at the stat key and right above that. Okay, and I'm doing this in the immediate mode. So do second function stat, list, right arrow over. Okay, there's number 5, sequence. They put them both as 5s. I like that. Okay, you got to go all the way over to the map menu. Okay, and pick up sum, number 5. Okay, in sequence, do the same thing. Do I got to do second function stat, right over to ops, and pick up sequence. Okay, now our expression. Okay, so we're going to put in sum, sequence. Okay, and our expression is going to be 3, and you're going to raise it to the x power, okay, and then plus 1. Okay, 3 to the x power plus 1. Okay, and then our variable, we're using x. You could use n or whatever, but I'm using the xt theta n key. The start would be 4, the end would be 7, and we're counting by ones because we're going 4, 5, 6, 7. Okay. Okay. Everybody get to the sum sequence? Okay. Okay, and then put in the 3 to the x power plus 1. You have to put in the commas. The comma is on a key by itself right above the number 7. On the 84, as long as it works, that's fine. You have a different operating system that's a little bit different than mine, and that's fine. As long as you get it to work, I'm a happy camper. Okay. Then put in the variable. Okay, and then put in the 4. And then put in the 7. Then put in the 1. Close the parentheses. Close the parentheses. Okay. Did you get the right answer? 3,000. Okay, 3,244. Did yours work okay? Okay. 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 Anybody need help? Okay. Okay. So you should get 3,244. Okay. Okay. Let's go through another. Okay, say I give you 2, the summation of 2 times the quantity, 1/3, and that 1/3 is to the n power, and n goes from 1. Now, here's the difference, 1 to infinity. Okay? Okay, so first thing you ought to do is show a pattern of at least 3. Okay, and these are still summation. So it's 2 times 1/3, and we're starting with the n is 1, plus 2 times 1/3 to the second, plus 2 times 1/3 to the third, plus ... because it goes to infinity. Without the plus ... you've written it wrong, and I'll take off at least 1. You know I will. Okay? Okay, so if we simplify this, order of operations, you do the exponents first. So 1/3 to the first is just 1/3 times 2, 2/3. 1/3 squared would be 1/9 times 2 would be 2/9. 1/3 cubed, 1/27. So that'd be 2/27 plus ... Now, you have to look at that and say, is that arithmetic or is that geometric? Geometric, okay, we know it's geometric. We also know it is infinite, geometric, and we're looking at a sum of an infinite geometric series. Okay, now you got to go back in what we've done before. Sum of an infinite geometric series. What's the formula? Can't be sub n. Yep, Braceland's got it. S equals A over 1 minus R. Now, when is there a sum? When is there an answer? Look in your notes. When does that formula work? Yep, if the absolute value of R is less than 1. What was our R over here? What would we multiply by? 1/3. Our R was 1/3. Is the absolute value of that less than 1? So yes. So we can find the sum. S equals, our A is 2/3. Our R is 1/3. Okay? Then we'd end up with 2/3. 3/3 minus 1/3 is 2/3. 2/3 divided by itself is 1. So the sum of this whole thing, I guess I don't need that dot dot. I need the dot dot dot. Don't need the plus. The sum is 1. Okay? Okay, final answer is 1. So, if it goes to infinity, okay, you have to maybe use another formula, okay, and figure out if this ratio was, say, 5, then what would the sum be? What? No sum exists. If the absolute value of R is greater than or equal to 1, no sum exists. Okay? So you have to be able to recall that information. Okay? So this one's the sum of an infinite geometric series. Okay? And that's the one that when we were going through that in the notes, I said that kind of bothers me because we don't know what the last terms are, and I just told you what the sum is. Okay? But that's where those terms get so infinitesimally small. Okay? Okay, now, I've given you the sigma notation. We've expanded it and find the sum. Let's go the other way. Okay? Change the directions. They will say in the book, write using summation or sigma notation. Summation or sigma notation. Okay, and let's say they give you the series. Remember, series are separated by plus or minus signs. Say I give you the series 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Okay? And I want a formula and a sigma notation that works to give me that series. Okay? What I always check first, and I check them in order, is it arithmetic? Is there a common difference? Yes. And if there is, then I use the formula A sub n equals A plus n minus 1 times d. If you're trying to find a formula to go out here, don't substitute in for A sub n and don't substitute in for n. Okay, so my A sub n would equal, my A is 1, don't substitute in for n, and common difference is 2. Okay, so A sub n would equal 1 plus 2n minus 2, so 2n minus 1. So that's my formula that's going to go over here. Now, if you use either this formula or the A sub n formula for geometric, your n will always start at 1. Okay? Now, sub n, if n is 1, does that generate 1? Yeah. If n is 2, does it generate 3? 2 times 2 is 4 minus 1. Yeah. Okay, when does it stop? This one you can probably tell, and you can look and say, okay, here's where n is 1, 2, 3, 4, 5, 6. If n is 7, that's where it stops. Let's say let's say this went on, for several, and I could not tell by sight. Okay, so then what you do is you go back and you use your formula, use your a sub n equals 2n minus 1, and put 13 in for that last term. Okay, and add 1, so you get 14 equals 2n, divide by 2, and n equals 7. And that's how you can figure out what goes up there on top. Okay. Now, when I'm doing the test, some of these, I always check, is it arithmetic? Is it geometric? If it's neither of those, I look for factorials. I look for perfect squares. If it's fractions, there's no common difference, there's no common ratio. Then I split up and I look just at the numerators, I look just at the denominators, and then after that it's trial and error. Okay? And on some of them on the test, I've actually got like maybe 5 correct answers that people have done by trial and error. And I will tell you, like, I can show you this problem, and then in the book, in the back of the book, the author has something totally different than this, and the author's correct, and I'm correct. The author might have started with a different formula and started with n as 0, okay? Or the author might have started with n as 4 or something like that and still be correct, okay? So don't think that you're wrong if you look in the back of this book and your answer is different than the author's, okay? Most of the time my answer is different than the author's, and we're both correct, okay? Okay, try another example. Okay, say same direction, right, using sigma notation. 16 plus 19 plus 22 plus 25 plus ... on up to 61. You need plus signs in between and the 3 dots. Okay. Common difference or common ratio? Difference. Okay, so same formula. And by now, you should have written that formula enough. Because I think right now at this point you've got like 6 formulas. 6 or 7 formulas. So you need to have these memorized. Whatever you have to do to learn a formula. Okay? I'm looking for the formula that goes out to the right. Don't substitute in for a sub n, and don't substitute in for n. This would be 16 plus n minus 1, common difference of 3. Okay, and now multiply this out. Okay, so my a sub n would equal 16 plus 3n minus 3. So I get 3n plus 13. Okay, so 3n plus 13 goes out at the side. My n is 1. If you use that formula, n's going to start at 1. Now, here's where I don't know on the 61, where do I stop? Okay, because I can't just count them. Okay, so I take my formula, my 3n plus 13 equals my a sub n, and my last term is 61. So sub n 61, subtract 13. Okay, what do I get? 48. Yep, and then divide by 3. So n equals 16, and that's what goes up here at the top. Okay, so you would start substituting in, and you should be able to generate that sequence. Okay, if n is 1, okay, and if n is 2, okay, if n is 3, okay, okay, okay. Any questions on that one? Okay, now you try this one. n plus 1. My sigma's a little bad on that one. Say I give you 3n plus 1 n equals 5 to 20. Okay, I want you to find the sum. Okay, so you should be able to use some sequence. 3x plus 1, variables x, start at 5, end at 20, count by 1, close the parentheses, close the parentheses. Get 616? Yes. Okay. Okay, take a break.